Who am I? Why am I here? Now, this is my tutorial on GObject in C, specifically in the context of GTK4. Basically, what we're going to do in this tutorial is go through some very fundamental basics of how to create a very simple custom widget using GTK4 and GObject, specifically in C. Now, I've seen a lot of tutorials out there, and I highly recommend, first off, that you watch Christian Hergert's video on the basics of GObject before you watch this video. That's not mandatory, but it will help because he really, first of all, he's a core developer of GTK, and he wrote GNOME Builder, which is a tremendous program. And so if you watch his video, he really knows what he's talking about. I'm not an expert the way that someone like he is. But I've seen a lot of tutorials out there, and a lot of them really are able to talk about either GObject or GTK, but nothing that really links together object-oriented programming, again, in C and with GObject. And again, GTK4 is pretty new as well. And so I've not seen many tutorials that cover that intersection of topics. So I'm going to try my best to show what I know about that, which is not much, but it should help some people. Now, the tutorial for GObject, the official tutorial, is actually quite good, and I'm going to be referencing that, and I'm going to link to that in the show notes as well. And the GTK API reference manual is tremendous, and I'll also be referencing that a lot in this video. But the difficulty is, how do you link it all together? How do you find the context of how to utilize all these subroutines and functions and methods and actually create something? So that's what I'm going to try to assist with. So I've got a series of files here. They're very heavily annotated, and what I'm going to do is put a link to the GitHub repo, or the GitLab repo rather, that has these items in it. And that way you'll be able to get the initial files and work with them with me. So we've got a simple make file here. I won't walk you too much through it. It's a boilerplate. Really, what we're going to be doing is building a binary called main. We're going to be building our demo widget.o, and our main will really just be displaying that widget and not really doing an awful lot else. And so we've got our commands here to use GCC and to do it under the following C flags, and to use the debugging symbols, and to build a binary that we'll just call main, just for simplicity's sake. And so let's get out of that. And let's start out by looking at the demo widget header file. Now, it's best to think about your GObjects in terms of one object per .c and .h file. And so one good way to remember that is when you build an object file using make or using GCC, you're going to get an object file, right? And so think about each object in GObject as being one of those object files. So let's start out by looking at the header file that I've called demo widget.h. And now don't worry about the first line, that just has my Vim mode lines that I like. So we've got our hash pragma once. That's the newfangled version of a header guard that just makes sure that if this header file happens to be included more than once when linking binaries, that it will only be included one time. And so you won't get any clashes of namespacing or anything like that. And so first we've got our #include of the GTK header, which is fairly standard. Now this pulls in the glib and the GObject header files that we need, so you don't need to go ahead and put those there as well. So we've got our gbegin decals and our gend decals. Now that basically just expands to extern C, which will only be something that will be expanded if you're using a C++ compiler. So really, in using pure C, this won't really make any difference, but it's doesn't hurt either to include these here, because if somebody wants to use your code in a C++ program, they can go ahead and do that, and they'll be able to do so. And so really what we've got here is some boilerplate code. Now, it actually makes sense to skip this pound define line and look at the GDeclare final type line. And now this is a macro, and this is a macro that's provided by the GObject headers. And basically what it goes ahead and does is it creates a whole series of subroutines that will be declared but not defined. And basically your job is then to create your constructors and destructors that will follow a certain pattern. Okay, so you start out, and the documentation is fairly clear on this, so I won't walk you through this now, but don't get too scared by how we have demo widget, demo widget, demo widget all repeated. Really think of it in terms of a namespace followed by your actual class name, namespace being demo, the class name being widget, and then you basically have to repeat those a couple of times in different formats for the macros to be able to create these subroutines for you. So 1, 2, 3, 4 here, all purely boilerplate. Just make sure that you do it the way that the format shows here. If you change widget here to fluffy, it'll work, but it's just going to create some macros and subroutines that are not going to be as expected under the GObject system. So it's really your job to make sure that you follow those conventions. The last parameter, though, is something that is somewhat customized, and really what it is that's what you're subclassing with this object. So we're going to subclass GTK widget, which is not the rawest form of GObject, but in the GTK system, it's about as low as you can get, okay? And then now it actually makes sense to look at this pound define line, and really, if you've utilized any GTK, you'll know that there's GTK underscore type underscore various things and G underscore type underscore various things. That's really your macro that gives you the G type, what it's called definition, and it expands to demo widget get type. And demo widget get type will actually be generated by this macro here. Okay, so don't overthink it. Just know that this is boilerplate. And the reason why we're using this macro called GDeclare final type is this is the simplest type of object that you can create in GObject, being a final type. There's also derivable types, and there's interfaces. We're not going to get into those at this time, but just know that a derivable type is one that you can actually subclass further in the GObject system, and you can pull in demo widget, in this case if we made it a derivable type, and you'd be able to expand upon that class. The problem with that is that if you are continuing to work on your program, continuing to work on your object, once you make it a derivable type, parts of your class and structure you kind of get locked into. Whereas with a final type, you're using pretty much only subroutines to get and set properties and to do various things. Or at least that's the expectation. And so according to the documentation, if you're not really sure what you want to be creating at the beginning, make it a final type at first, and then you can always make it a derivable type later on. So there's that aspect of it, and also the fact that the final type is a much simpler object type. So it does make sense for our tutorial to start with that. Okay. And then you're going to have your method declarations, really, which is what the public interface will use in order to actually create your object and to do things with it. And so if you've used any GTK, you'll know that there's lots and lots of these subroutines that end with underscore new. And so really you're following that convention in creating your own method or subroutine that uses that format. So you'll know that there's GTK label new, for example, that will create a new GTK label, but it will return a GTK widget. And so really we're following that convention, and we're creating our demo widget, and it's going to return a GTK widget star. And so that will be not a mandatory item, but it will be something that your users will expect to see. And so by minimum, you really want to be including a underscore new method. And so that's why we have gone ahead and defined or declared that for now, knowing that we'll have to define that and set that up in our actual code. And so I know that was a long-winded explanation, but really 18 lines long, not too bad for our header file. And as a user, all you really need to do is look at our method here as a library user of our demo widget to know that that is how you'll create our widget. So we're going to quit that. We're going to go ahead and look at our actual .c file now. And so I've got lots and lots of comments in this file. And I'm going to actually go ahead and explain some of them and then delete those comments and leave you with a sort of good template that you'll be able to use. And so on the GitLab repo, this .c file with all the comments is there. And so you can go ahead and use that as a decent template to start a very simple object using GTK. But you'll probably want to get rid of some of these comments because it is fairly verbose. Okay, so here's our comment here that just explains that what this is an annotated C file. I put the dependencies there. You're going to need glib greater than or equal to 2.44, and you're going to need GTK at least version 4.0. And so I kind of already explained what derivable versus final means. So we're going to go ahead and delete these comments right here. We're going to, of course, include our header file. And I recognize that, you know, this is demo widget.c. Now we're creating, we already created our demo widget.h. So we're not going to do anything except create the actual guts of the object here. We're not going to create a main function. It's almost like we're making a library. Well, we basically are creating a library, okay? So now, first we have our internal declarations, which really what they are is a couple of methods that we're going to do forward declarations of. You don't have to do this because you could just go ahead and make sure that you define these methods above the other boilerplate methods, but I like to put them here because I think it's a little bit, it's not strange, but it's a bit, it did trip me up at first that you have these methods that are going to be expected to be there, the dispose and the finalize, or they may be expected to be there, but they're not actually declared by the macros. And so I'm thinking that what they do by default is just chain up, it's called. We'll get into that in a moment. Chain up to the parent class and just run the parent class's dispose and finalize virtual functions. But I like to put them in here. I think it's good practice to do so because typically you're going to be expanding on them anyway. And so I think it makes the most sense to make sure that you go ahead and define them. And because we're defining them, I want to put the forward declarations right here at the start so that we don't, you know, make a stupid mistake by putting them out of order and getting a stupid error. So I'm going to go ahead and delete this comment now. Now, way back when, and I'm actually going to create a new tab here, and I'm going to open our old header file. So remember when we ran this macro here, what that went ahead and did was it created a whole whack of declarations, created them, auto-generated them using the macro. And one thing that it did was it created something along the lines of a type def struct underscore demo widget. And so because that happened automatically in the macro, we don't need to say that here now. But what we do need to go ahead and do is actually define what struct underscore demo widget does, because if we don't do this, the macro, our build is going to fail. It's going to say, well, where's your definition of underscore demo widget? And you're going to say, well, I don't even know what that is, but you're supposed to know because you're using GObject, and part of the documentation says that when you run that macro, you're expected to define the struct underscore of if I can only get there. Where are we? This guy right here, demo widget, okay? So underscore demo widget. Now, one thing to understand is that GObject taps into an element of the C standard, and it really relies upon this. It says that, look, if you refer to a pointer to the first to a struct itself, that will be equivalent to the first item within the struct. Okay, and so GObject utilizes that by always putting the entirety of the parent class as the first member of the struct. And so this is why we put GTK widget but no star, because we're putting the actual structure itself as the first member of the underscore demo widget struct. And the interesting thing about that is if you keep tracing the roots back up to the bare class of GObject, which would be GObject itself, then the initial parent class of GTK widget will be shoved into that struct, and so on and so forth, until you get to GObject, which is the first in the hierarchy. And so you can always cast to any of the parent classes as a struct, if you think about it as a struct, and be able to access the members. And that's really the heart of GObject. So we're going to go ahead and put that as our first member. I'm going to delete this comment because anybody who uses GObject and has had some familiarity with it will know that that's just what you do. And so I don't need that comment in there. And then here's where you go ahead and add your additional members. And the additional members of your class will be pointers. Okay. And so what our class is going to be, our custom widget is really just going to be just a really dumb button. And the button is going to be actually less customizable than a regular GTK button. And that's just not an exercise that we're doing to represent reality, but we're just trying to do an academic exercise. So let's just go ahead and delete this comment here, because we know what that struct format should look like. Okay. So once we have defined that struct, what we then need to do is take sort of the C equivalent of this GDeclareFinalType macro, which is GDefineType, and that's what we put in the actual C file. And again, the first two entries are boilerplate. The last entry is the actual GType macro that expands to the GType that we're looking for. And so it needs to marry up with what you put in the header file. And so GTK widget, the equivalent GType macro would be GTK underscore type underscore widget. And so that needs to match up with that. And you can always look to the documentation to know what it will be, but because the macros were all used to create the actual items within GTK, you learn at a certain point that they all start to follow a certain format. And so, for example, GTK button, the GType macro would be GTK type button. And you see as soon as I enter the N there, it turns purple because I've got my syntax highlighting on that will show that that is the that's the recognized GType macro. Okay, so just be aware of that, because you put the actual data structure name in the DeclareFinalType macro in the header, but then you put the GType macro, which is all caps, in the C file. So just be aware of that distinction there. Okay. Now, because we've explained that, I'm going to delete those comments there. Okay. And so now we have to actually go ahead and define our methods, which are basically our constructors and destructors and everything that, if you were thinking of C++, for example, would be things where you wouldn't be putting these prefixes at the beginning of everything. You'd just be saying self hyphen init or something of that nature. But in GObject, really what you're doing is these subroutines are getting declared in a way where it's expecting you to follow a certain format. And now in the documentation, they call this the instance init function. And that's true because the virtual function is called instance init, but the actual C function that they're expecting you to define is demo widget underscore init, not instance init. So just again, be aware of that. Make sure that you follow the format. You can always use this template if you're not sure. So we're going to delete that. And the reason why we're calling these static void is because these will not be publicly accessible from our API. They can only be called from within this object, meaning the library itself, the object file, not the GObject. Okay, so recall that I keep doing that. I'm not used to this keyboard. Recall that the only public method declaration that we've defined or we've declared in the header file is the demo widget new, and so that's the only one that will not be defined as static in our C file. And so the instance init function will just you're expected to have the one and only parameter be a pointer to the object itself, which is demo widget. And you could, you don't have to call this self. You could call this fluffy, or you can call it this, or whatever you like. But the convention is to call it self, and so we're going to go ahead and do that. So the first subroutine that we're going to define is our init function, and you don't have to do this first line here, but it is very helpful to create a shorthand for self that's cast to the GTK widget and call it widget. Otherwise, you're going to be having all kinds of individual casts to GTK widget all throughout your init function. If you've used some GTK, you'll know that this is a pretty standard way of casting using their macros, and it basically allows you to cast from one type of GObject to another without getting weirdo warnings about casting from incompatible types. And so this is a bit of a tangent, but a bit of a common convention is after you have put a function name in place, you'll put a space before you put the parameters in brackets. What I like to do is when I'm using a macro that is primarily used as a cast, I won't put a space to show that it's a cast. And now this is actually atypical. You're going to see most code keeping the space in there for all of the subroutines and the macros, but I like to do this to distinguish between the two of them, to show that this is a macro cast. I just like to not have the space there under those circumstances. But it's more idiomatic in GTK and GObject programming to put spaces between all those brackets, but I don't really care for that. So we could technically, if we wanted to, just delete all this and have an empty init function that does nothing, and we get basically a blank widget. But I wanted to have something appear on the screen. So create our shorthand. Now we're going to do self arrow button is equal to, we're going to create a GTK button. We're going to give it a label. By default, it will be hello world, okay? And recall up here, we created a pointer to a button in our struct, so that will allow us to do self arrow button. And to actually go ahead and define that. Otherwise, it's going to initialize to null because this is a global structure. Okay. We're going to just run some standard GTK subroutines on our button. We're going to make sure that it expands to fill up the entirety of the widget, and now this is important. We're going to set the parent of the button to be our widget, which, remember, widget here is a shorthand for self cast to GTK widget. If we didn't do this, we would just basically create a button in a vacuum that wouldn't be connected to our actual demo widget. Okay, you don't want to do that because you're going to probably create a memory leak. You might actually get a warning from GTK at some point saying, hey, you didn't actually do anything with this thing. Probably not actually, but you might create a memory leak. So don't do that. Now, the next subroutine that we're going to define is our dispose method. So there's two stages to destructors in GObject, and this comment that I have here kind of explains it. But if you're using something GObject-y, anything involving GTK for the most part, it'll be what's called ref counted, meaning when you create an instance of the object, and if you make it a parent of something, or if you connect it to another object, then the reference count will be incremented by 1 each time you do that. And so you don't just create an object and then free it. You have different levels of references, and then once that reference count reaches 0, it's then freed and the memory is then returned to the system. And so what they try to do is break up the process between ref counted objects and things that can't really fit into that system, like a file star pointer, which is part of the C standard library, and that more than predates GObject and references. So you want to do that kind of thing, have that kind of thing freed in the finalize subroutine as opposed to dispose. So we're going to delete this comment here. Now, because the parameter that gets passed to a standard dispose function is a GObject star, it's helpful to cast that to our type of a widget, which is a demo widget, and to create our self right here. And so note that I didn't explicitly define the demo widget macro cast anywhere. That gets done right here in our GTK4 macro, and so that happens automatically. And so our destructor is basically going to be to do the opposite command, or the opposite function of a set parent, which is an unparent, and that just takes one parameter, being a GTK widget. So that is for self hyphen button, or self arrow button. So anybody who is really paying attention will notice that this cast is actually not necessary, because self arrow button is already a GTK widget. So we can go ahead and delete that cast right there, and it should have worked just fine. And now it's good to keep this as the final step. And I'm thinking that if we hadn't overridden the dispose virtual functions way up, no, we haven't done that yet. We'll get to that in a second, but if we hadn't defined and declared the dispose subroutine, I think it would do this itself automatically, but don't quote me on that. You have to do what's called chaining up, which is where you take the parent class of the object and then run its dispose virtual function. And so I'm going to keep this piece of the comment here, but delete the rest, because I think it's important to show that that's a final step and it's boilerplate, but let's keep that at the end, and we'll keep the comment a little more concise. We just talked about what the difference between finalize and dispose was, so we'll delete these comments here. I'm just going to go ahead and keep these comments here. If we do need to add something later on to the finalize subroutine, we will, but for now we're going to keep it boilerplate and chain up to the parent class and run its finalize method. So we're going to continue here. So those two subroutines are the destructor functions that we had to actually manually, if you recall, put our forward declarations here, because they're not automatically defined by the macros. Now you may be wondering, well, how do they actually get called then? We'll see that in a moment. So with the class in it, what you want to go ahead and do is follow the boilerplate format. Now this is a subroutine that that is automatically declared by the macros, and so it's typically going to be something that you will want to populate in some fashion. So this method gets run the first time the class is ever used, but then not again. And so it is the I don't know what you call it in C++ terminology, but really what it is it's not going to get run every time you create a new demo widget, but it'll be run the first time that you create an instance of the class. Okay, so we'll delete this comment here, but one thing that's important well, not important, but nothing in the documentation says why they keep spelling class with a K like this. And the reason for that is because class with a C is a reserved word in C++, so they wanted to avoid using that word to make sure that they don't have any namespacing collisions with reserved words in C++. So, just in case you were wondering, that's why we keep using class with a K like that. You could call it class with a C if you're quite sure that you'll never be invoking any of these libraries in C++, but I think it's better practice to use the K there. And so that's what we're going to do. So because they expect you to actually go ahead and override the virtual functions from what's called the GObject class, object class type, as opposed to your own structure. It's helpful, and for other reasons too, because if you keep using the GObject class, and you keep using functions that are going to expecting that type of data structure, it is helpful to create a shorthand for GObject class here and just cast using a standard macro to the class with a K. Okay, and then to override basically these virtual functions to allow you to create your own dispose and finalize functions, as we've already done. Okay, you're going to want to go ahead and override those virtual functions by doing object underscore class arrow dispose is equal to your subroutine, or it's really a function pointer to that subroutine, and again the finalize. And this is why it's important to make sure that you actually follow the parameters in the dispose and finalize subroutines that we used above, because otherwise it's going to say, hey, the prototypes that you have used don't match up with what we expect to see for these virtual functions of the dispose and the finalize for object class. So just be aware of that. And just follow the formula. All right. Okay, so that's boilerplate. But here, this is an important function to run here. So if we didn't run this function, and if we didn't set a layout manager, it wouldn't know how to actually display our button on our widget. So there's various types of layout managers that you can utilize, but we're going to use the box layout type. And so what you do is you run GTK widget class set layout manager type, then it expects to get a GTK widget class pointer, and so we don't have that at our disposal here. We have an object class and we have a demo widget class, so we're just going to type out the class manually here and cast with our macro. You could just as easily, if you'd like, go GTK widget class star widget class is equal to GTK widget class bracket class, like that. Then you could just pass widget class like that if you'd like, but I don't really see the point in doing that for literally one time that we're running that. So I just put the cast in there directly. Okay. And again, this type of layout, G type, is going to be expected. You can't, you have to call one that it expects to see. I believe another one is bin layout. There's a few others, but we're going to use the box layout for now. Okay. And finally, we're going to define our demo widget new subroutine, which we have declared here. That's our only public function for now. And luckily, it's completely boilerplate for now. So just copy and paste it, at least for now. I'm going to make a new comment here called public method definitions, and just to make sure that we can see our code nicely laid out. And really what we're doing is, this is really a convenience function for running GObject new demo type widget null. You may be wondering, why is it null? What could be passed there? What you could pass are object properties to initialize that object with GObject, but for now we don't have any properties for our object, or at least none that we want to, at least none in the hierarchy that go above our demo widget that we want to be going ahead and setting now. So we're going to pass null to that just to create a regular vanilla GObject with of the type demo type widget. Again, this G type follows the convention, just like this one right here, for example, of GTK type box layout, right? And it returns that type of object. Now, GObject new would typically return a GObject, but because we've defined it as returning a GTK widget, that will be the type that's returned. We don't need an explicit cast for that reason. So that's, okay, bit of a mouthful there, but let's save that. Let's go ahead and run make. Everything works fine. Now let's go ahead and run our main function, and here we go. All that rigmarole for a window to pop up with our button that says hello world, as we expected. It expands the entirety of the window. We can click on it, it does absolutely nothing, but that's not the point. The point is that we have created technically a custom widget of the type demo widget. And now to show you the actual application code that we've used to actually make that work, we have a very, very boilerplate stub main.c file that will basically just create a window. It'll create our demo widget, and we've used our demo widget new function that we created with GObject, and we're creating a window, a standard window of size 400 by 400. We're literally just setting the direct child of that window to be the demo widget. We're showing the window, and then here's our boilerplate code to just run the GTK application. I'm not going to walk you through all that now. It's basically just from the tutorial documentation of GTK, slightly modified to show our custom widget. This will all be, well, this is all posted on the GitLab repo, and I'll post a link for you for that in the show notes. And that's basically it for this episode. Next time we're going to get a little more in depth. We'll start to show how to add some properties to our GObject. That'll be the next step. And I know that doesn't sound like much, but that is actually quite a bit of code that's going to be changed, and a lot of new things to understand. So we're going to make that a whole separate episode. Yeah, thanks for watching. Good night and good luck.